Welcome to video number 55 in the Using iTrain tutorials series. My name is Bob Fuller. In this tutorial we will be running through each of the 8 AND-based scenario exercises and seeing how to correctly use static and dynamic condition elements. Welcome back. So we are going to see which of these scenarios will trigger the execution of the action and which will not. We will also be highlighting exactly when each action is triggered, because the timing of the execution can be equally as important in the operation of the layout. So not just if they execute, but also when they execute. But let's first talk about static and dynamic elements. These are not official iTrain terms. I use them in these tutorials to help distinguish which condition elements need a little more care when used in an AND group. Here is an updated table which includes a new column called category, which shows whether an element is static or dynamic, and another column that is called testable states. These are the testable states for each element. So they are the states that we set when we create the condition, and which we will see called the reference states in the scenario exercises. More on that later. So we have dual mode and trigger only elements, which we can further categorize into static and dynamic. Static elements, which are the feedbacks, aspects and relays, can be used as many times as we like in a group without affecting the outcome of the action. And the order in which their events occur on the physical layout will also typically not affect the outcome of the action. And static elements are very well defined stable states, and it is easy for us as users to determine what state they are in. For example, it is easy to obtain a visual indication on the switchboard of their current state, and that state remains stable or static. All the other elements, including the trigger only elements, we will categorize as dynamic. Now, even though some of these may technically be static elements, I'm proposing that we treat them as dynamic, because it means their states are either momentary, moving to one state and then quickly back to another, or it means their states are difficult for us as users to visually determine, or there is something different about their operation. For example, they may not be simply on and off type elements, or we may not be able to test all of its possible states, or the operation may vary in some way depending on how it is being used. Trigger-only elements are extreme forms of dynamic elements, and in the last tutorial we already defined rules for how trigger-only elements should be used. There should be only one trigger-only element in any AND group, and it needs to be the last event in the sequence of events that occurs on the physical layout. So, very simple, we have static elements which can be used more or less as we like in any order and in any number in an AND group. Dynamic elements often need a little more care and attention about how many are being used together, their order in the sequence of events, and we need to know exactly how they operate. Okay, so let's start working through the scenarios and see if we can bring things into context. Now, this is rather a long tutorial, 30 minutes in total, which is a little too long to expect you to sit through it all. So what I recommend is that you just jump to the scenarios where you had any difficulties or if you didn't get the answer correct. So I'm going to give you the answer now. The scenarios that did execute were number 1, 2, 4, 5 and 7. So if you had any difficulties with any of the scenarios, use the time codes that are shown in the comments below the video and then go to that particular scenario. Now, even if you got all of these correct, I still recommend that you look at scenario number 1 because there's a tip there that is quite useful. You should look at scenario number 4 because there actually is a problem with that scenario. And have a look at scenario number 7 because there's something interesting about that particular scenario. Okay, so scenario number 1. Now the trick for all of these scenarios is to always first check what the reference states are for each of the inputs. So remember, the reference state is the state that we are testing for in the condition. Let me quickly show you as a reminder. We set the reference state when we select the state in the condition here. So here we have the feedback selected in the condition tab, and down here we have the state. So we can set as our reference state for a feedback either on or off. We are testing for a feedback being on if the reference state is set to on, and we are testing for a feedback being off if the reference state is set to off. Because these tests are comparison tests. They are always comparing one input against the other input, and the only time these tests will be true is when both of these inputs are at the same state. So if both the reference states are in the on state, then we know that the only time that both of these outputs will be true is when both of these inputs are in the on state at the same time. And if we look at these two state maps, the only place where that occurs is here. So we can already say that this will be the trigger point for the execution of the sound file, because this is the only place where both of the states are on at the same time. So with practice, you can already tell that this scenario will execute. Where we often make mistakes in actions is not noting or forgetting that one of the inputs has a reference state which is the off state, and that does affect when the action will execute, as we will see later. Okay, so both have reference states which are on, both states are off, so the output of these tests here will be false at that time. Move the timeline forward. We come to the first event. This turns on, matches the reference, so its output becomes true. Down here it is in the off state, so this will be false. True and a false means false there. Move the timeline on. We then come to block enter turning on. The states now match. This will come high, denoting true. Here the state has not changed, it remains true, so we have true and true, which produces a true. The condition is met. The commands will now execute and the sound file plays. So in this example, this block enter event was the trigger that started the chain of events ending in the sound file being played. So iTrain used this event here as the trigger, and here it was using the state of the feedback. Okay, scenario number 2. First, check the reference states. They are both the on state. So we know the only time that this will execute is where there is a window where both states are in the on state. And that can only occur at this time here. So we can already tell that this will be the trigger point for the execution, because that is the start of when both of the inputs are in their on state. Walking through the timeline, initially they're both in their off states, which is different to the reference states, so these outputs will both be false. We move the timeline forward. It meets the first event, which is block enter turning on. These two therefore match. Its output becomes true. Here it's in its off state, so that will be false. The output here is false. Move the timeline on. Feedback turns on, so these now match. That becomes true. True and a true produces a true, and the sound file will be executed. So in this scenario, the feedback event acted as the trigger, and the block enter was used for the state. So on to scenario number 3. Check the reference states. They're both set in the on state, so the only time that this is going to trigger is when both of these are in the on state at the same time. And if we look at these two state maps, there is at no point a window where they are both in the on state together. So already we should be able to tell that this is not going to execute. At the initial start, they are both in the off states, so these will be false here. Move the timeline forward. Block enter occurs here, so the output becomes true. Here it will be false. Move the timeline forward. This is false here, of course, sorry. Move the timeline forward. The next event is block enter now turning off. So the output here will become false. This is still in its off state, so will be false. So the output here is false. Move the timeline on. Feedback turns on, so this output will go high. We now have this in its off state, so this is false. So we have a true and a false, which is a false. So for scenario number 3, the sound file is never executed. Okay, scenario number 4. Now this is the scenario that has a fundamental error in it. Are you able to spot it now? I'm going to run through it first and then I'll tell you what the fundamental error is. So we take the same approach. We first have a look at what the reference states are. Now this has an on state, but this one has an off reference state. So the only time where this action can trigger is when block enter is in its off state and this is in its on state. So if we look at this here, it would appear that the only time that this could execute is at this event here when this is on and this is off. So it appears as if the sound file will execute. Let's run through it. The initial states are both in the off state. So this time that means that this output will be false because they're different, but this is off and the reference is off, so the output of this test will actually be true because remember the tests are comparing to check if the two inputs are the same state. Off and off are the same, so this is true. Okay, so we have a false and a true and a false therefore on the output of the AND. Bring the timeline forward. We hit the first event, which is block enter turning on. So now we have on and off, which means this will go to false. This state is still in its off state, so this remains false. So we have false and a false, which will produce a false here. Now if we move the timeline on again, now block enter turns off, so we have off and at off, they're the same, so this goes to true, but at this point this is still false, so we have a false and a true and false here. If we move the timeline on again, where the feedback now turns on, so these two inputs are now the same. We have a true here, This is still in its false state, so those are both the same. So this remains true. We have a true and a true, which produces a true here. The condition will have been met, and the sound file would execute, it would seem. But there is a fundamental problem with the scenario that I have set you here, and that problem is this reference off state here. For block enter, and in fact for any of the block element commands conditions, there is no off reference state. The reference state will always be the on or active state. So, although the logic described for this scenario was correct, the off reference state for block enter is not something that we are able to specify in the condition. And in fact, for all the block conditions, we can only specify and therefore test for the active or on state. And just to show you that, so here is the action and the condition. Here is our block element. If we click on it, we look at the states down here. The only thing you can enter or select for the states is each of the types of states, enter, reserve, etc. And when we select one of those, we are always looking for that particular state to be active. There isn't an option for it to be in its off state. So my apologies for the error. It was still a valuable exercise to run through the operation, and it will help us when we come to one of the other scenarios where we have a reference state which is off. Okay, scenario number 5. So this is different because now we have a block leave element instead of the block enter. This is still what we call a dynamic event or dynamic element, but it's of the trigger only type. We still approach it in the same way, so we first check to see what the reference states are. They're both the on state, so we know the only time that this would be able to execute is when they are both in the on states. And if we look at these waveforms, the only time that that would occur is here. So it looks like this will execute. The initial states are both in their off states, so these will both be false. We then move the timeline on. The feedback turns on first here at this point, so this will become true. This is still false. True and a false is a false. We move the timeline on and we get to the block leave event where it turns on. It is brief, but it's enough for iTrain to be able to detect. So we have on and an on. This test will become true. This is still in its on state, so is true. So now we have a true and a true, which produces a true here. The condition is now met and the sound file executes. So here the trigger only has acted as the trigger for this scenario, and feedback is being used as the state. Scenario number 6. The reference states are both the on state. The only time this is going to execute is if these are both in the on state at the same time. Well, That doesn't look as though that is occurring here, does it? Let's start off with the initial states, which are both off. So these will both be false. False and a false produces a false. Bring the timeline forward till we hit the block leave event. That goes to on, so this becomes true. This is still in its off state. False and a true produces a false. If we move the timeline on again, block leave has now finished, so it is in its off state. This is turning to its on state, so that will become true. This now has changed to its off state here, so this will become false. We have a true and a false, which produces a false. So scenario number 6 never executes. Okay, scenario number 7. So let's first check the reference states. Feedback has an off reference state, and block leave has an on reference state. So let's check to see what the initial outputs here will be. This is in its off state, which matches the reference, so this output will be high. This is off against a reference on, so that will be false. Move the timeline on. Block leave goes to its on state, so this becomes true. This is in its off state still, which matches the reference state, so that remains true. So we have a true and a true, which produces a true from the AND group. The condition is met, and so the sound file triggers at precisely this point when the feedback is in its off state. And I think it's worth playing this through to its conclusion. So we'll bring the timeline on just out of interest. So now we come to the feedback turning on. This will be on, the reference is off, so it now goes to its false state. Here we will have off and on, so this goes to its false state. False and a false produces a false. So from this trigger point onwards, the sound file is not going to play again. But do you notice something else about this scenario? And it's something I've only just noticed by going through this operation here. This scenario actually breaks our rule number 2, which said that if an action contains a trigger only element, that event must be the last in the sequence of events that occurs on the physical layout. Otherwise, the action will never trigger. Well, that, it appears now, is only true when we have reference states that are the on reference state. If we have any of the static elements where the reference state is off, then, as we can see here, the trigger only element needs to be the first event to occur in the sequence of events. So it looks like there is a little refinement needed to that rule. The last event to occur in this scenario is the feedback turning on. Okay, so scenario number 8, the last one, thank goodness. So go through the same routine. Let's check these states first. So we have an off state for the feedback and on for the block leave. So initially we will have off and off here, which means this will be true. Down here we have off against on, so that will be false. False from the output of the AND. Move the timeline forward, and this time the feedback turns on first, so this goes to on, that is off. This will then become false. Down here we have off and on, so that remains false. False and a false is a false. Bring this on. We now have block leave turning on. On and on produces a true here, but this is in its on state, which does not match the off state. This remains false, so we have a false and a true, which produces a false. So in this scenario, the sound file never triggers, despite the block leave event occurring when the feedback is on, because our reference state is the off state. So the answers to the scenarios as I had presented them were that scenario 1, 2, 4, 5 and 7 would execute the sound file. But now with the knowledge that scenario 4 is in real life something that could not happen. So well done to all of those that were brave enough to show their answers in the comments. Okay, that was a long tutorial, so let's quickly recap. Static elements can be used more or less as we like in any order and in any number in an AND group without affecting the action's outcome. And we are also able to test for any of their possible states at any time. Dynamic elements often need a little more care and attention about how and how many are used together in an AND group. Their order in the sequence of events can affect the outcome of the action. We may not be able to test all their possible states. For example, the time and all of the block elements, we are only able to test for its momentary on state. We also learnt the importance of noting the reference state. That's the state that we set when we create the condition. Elements with an off reference state will reverse the logic that determines if an action will execute or not. And it also reverses the order in which trigger-only elements should occur on the physical layout. And lastly, it is important to know how each condition element operates. The user manual is not particularly explicit in that respect. So, in the next tutorial, we will run through the operation of each condition element. You might be surprised by what you see. Hope to see you then. Thanks for watching.